Hello class, I'm Miss Bratton and I'm here to present to you the beginning of our unit Newton, 3 Laws from the Father of Physics. We're going to learn about Sir Isaac Newton's 3 Laws of Motion. Here's a picture of Sir Isaac Newton. He was born on Christmas Day in 1642 in England. He lived to be 84 years old, and during that time he made tremendous contributions to almost every area of math and science. In this image here, he is depicted with some of his most iconic discoveries, including the apple tree, which people say a falling apple helped him discover the law of gravity. In his areas of influence were physics, optics, and math, and I have a few illustrations here that I'll tell you more about. He discovered the laws of motion, which we're going to discuss in this unit. He also discovered the universal law of gravitation, and his ability to use mathematical descriptions of gravity to derive Kepler's law of planetary motion and the trajectories of comets removed any last doubts about the sun being the center of our solar system. He also used his models to calculate and estimate the progression of the tides and the seasonal equinoxes and other natural phenomena. He was also the first to predict the Earth would be shaped as an oblate spheroid. That means it's not a perfect sphere. It's fatter in the middle and a little shorter from pole to pole. And he was the first to predict that, and it has since been proven to be true. He also made contributions to the field of optics. He built the first practical reflecting telescope. This picture here is the second one he made that he presented to the Scientific Society in England. He also developed the theory of color based on the observation that a prism decomposes white light into the many colors of the visible spectrum, and he proposed primary and secondary colors and developed the color wheel, which people use today in art. He also invented differential calculus and many, many more things in the area of math. He was a man who knew a lot about a lot of things. For us to learn a lot about his laws of motion, we need to be familiar with some important vocabulary words that I'm going to introduce to you now. The first thing we need to understand is mass. The classical definition of mass is the amount of matter in an object. And what is matter? Well, all matter is made up of atoms. So when we talk about the mass of an object, we're talking about the amount of protons and neutrons within that object. It is measured typically in kilograms using a balance scale. If you can imagine a balance scale, it has the 2 plates, and you put a known mass on one side until you can balance the mass of an unknown on the other side. That's how we measure mass of an object. Do not get mass confused with weight, which is the pull of gravity on an object. This is often used to measure mass, but weight changes depending on how much gravity is pulling on an object. For example, an object with the same mass weighs less on the moon than on the Earth because there is less gravity. You see here that the spaceman standing on the Earth and the spaceman standing on the moon have the same mass, 100 kilograms, but the weight is dramatically different. The weight on Earth is measured here in newtons. It's 980 newtons, and on the moon he's only 162 newtons. So don't get mass and weight confused. We also need to be familiar with the term inertia. Inertia is the resistance of any physical object to a change in its state of motion. That sounds complex, but that means that the resistance this little orange man feels when he tries to get the boulder moving is inertia. But it also means that the resistance this man would feel if he tried to stand in front of a rolling boulder and stop his motion is also inertia. People often say that an object wants to stay the way it is. If it's sitting still, it wants to stay still. If it's moving, it wants to keep moving. And that is inertia. We also need to understand force. Force is the strength and direction of a push or pull upon an object. You can see these guys pulling in opposite directions. That's force. And you can see this man pushing this cart. If he pushes it harder, with more force, you get an increase in the strength of that force in that direction. We also need to remember what velocity is. Velocity is the distance traveled from a starting point in a given amount of time. Remember how we talked about mass and weight often getting confused? Well, speed and velocity are often interchanged. But we need to remember that velocity takes into account direction as well as speed. So for example, if you travel in a circle and come back to your starting point, although your speed might have been quite fast, your velocity would be 0 because you have not moved from the starting point. So don't get speed and velocity confused. We also need to remember acceleration, which is different than velocity. It is the change in velocity in a given amount of time. So acceleration is the rate of change in velocity. So if you look at this man on this cyclist, you can tell that when 1 second has passed, he is going 1 meter per second. That's his speed. At 2 seconds, his speed is 2 meters per second. At 3 seconds, 3 meters per second. So he is accelerating, and we would say he is accelerating at 1 meter per second because every second he is going 1 meter per second faster. So it's an increase or change. It could also be negative. It could be a decrease in velocity in a given amount of time. And the last word you need to be comfortable with is friction. Friction is the resistance caused by two things rubbing against each other. I thought this picture was a great illustration. There are no perfectly smooth surfaces on Earth. Therefore, there are bumps and ridges. You may have to look very close to see them, maybe even under a microscope, but they're there. And these ridges cause forces when they rub against each other. They bump against each other. And they diminish the velocity of a moving object. So when two things rub against each other, these bumps and ridges bump against each other, and they slow an object down. This is called friction. Now you have the tools. If you understand these words, you are well on your way to learning more and understanding Newton's 3 laws of motion. If you feel you need to review, please feel free to watch this video again. But if not, I have put together quite a selection of nice videos for you. So I hope at the end of this, you will enjoy and know as much about Newton's 3 laws of motion as possible. I'm excited to learn with you.